Definition of a parallelogram. So parallelogram is a quadrilateral. So because it's a quadrilateral, that means that we know it has 4 sides. We know that the interior angles add up to 360. We know that the exterior angles add up to 360. So all of that is taken care of under the word quadrilateral. So a parallelogram is a quadrilateral with both pairs of opposite sides being parallel. Hence the word parallelogram, because it has opposite sides parallel. So on our parallelogram that you should have been writing your definition, that's a really bad parallelogram. Those are not parallel sides. Let's show the parallel parts. So how do we show parallel?
That's not.
We're going to pretend that it is the triangles. So let's say that the top and the bottom are parallel by putting the single triangles there.
Isn't there like a line tool?
That shows congruency.
I thought there should be a line tool.
Nope. And then we'll show the left and the right parallel with each other by putting double triangles. Okay? So that's why we call it a parallelogram, because it has opposite sides that are parallel to each other. Okay? Now, we've got a bunch of theorems about parallelograms. They're all pretty obvious. The first one states, if a quadrilateral is a parallelogram, then its opposite sides are going to be congruent. You can make a quick picture. You don't need to put the key Q, P, R, S in there. Just make a parallelogram, show congruency on your opposite sides. So if this was 8, this would be 8. If this was 5, this would be 5. If this was 5 and this was X, what would X be? It would be 5. What?
We also make sure not to make all the sides the same length, because that's a rhombus.
Right. But a rhombus technically is a parallelogram.
It's like a square is a special type of rectangle, and a rhombus is a special type of parallelogram.
Exactly. All right. If a quadrilateral is a parallelogram, then its opposite angles are congruent. And you can make a quick picture of that. So opposite angles are congruent. Now, there are some proofs that do come into play in Chapter 8. We are not going to do them, but don't be surprised if you see one as like a bonus problem. Let's quickly do a quick informal proof of this. If QR was parallel to, let's say, PS. So these are my parallel lines. And these are this is my transversal. Marker's dying. What's true about the measure of angle R plus the measure of angle S? Nope. What's true about R and S, the measure of those? They add up and equal to what? 180. Why? If lines are parallel, then what?
Then they equal 180.
Then what specifically? What type of angles are they? Huh? No. Think back to Chapter 4. Alternate interior congruent. You're on the right page, Harlan. Which ones are supplementary?
On S?
They're interior. What's the word that goes in front of them?
Supplement?
Alternate would be this. They're on the same side. We call that, consecutive. So Harlan, you got us going. So then, consecutive interior angles are supplementary.
Which one is this for?
This is just a sidebar. You're not writing any of this down.
Oh.
Just going through this with me. If we said that QP is parallel to RS, then what would be true about the measure of angle Q plus the measure of angle R? Their sums should be what? 180. Same justification, right? So just ditto mark that. Now, look at this and look at this. What property allows me to eliminate that and say that the measure of angle R plus the measure of angle S equals the measure of angle Q plus the measure of angle R? Do you guys remember that property? Not reflexive. Reflexive is when it's equal to each other. You're on the right thinking track, though. If we take out the link, this is our favorite one, right? Transitive. That one happened a lot. Then what property allows me to then say the measure of angle S is congruent or equal to the measure of angle Q? What happened from here to here? What'd you say?
Subtraction.
Yeah, subtraction, because we can subtract it from both sides. So subtraction property. And because of our definition of congruency, if the measures are equal, then the angles are equal. Is S and Q opposite angles? Yeah, so I just proved this theorem. Why opposite angles are congruent. You are not going to need to know how to do that. But it was good to get our brains thinking back into proof form. All right, so we got that one. Let's look at this first example. Let's first solve for x. Notice x is on a side length. What did our theorem say about opposite sides? They're congruent, so what's my equation going to be? X plus 4 equals 12. As simple as that, so x is equal to 8. Now let's look at y. Y is inside an angle. What does our theorem say about angles? So what's y going to equal?
65.
There we go. Easy as that. Next one's even easier.
X equals 66.
What is x equal to?
66.
Yeah. So notice the difference in the directions. The previous example said find the values of x and y. They gave us the parallel sides with the triangles on it, right? So because they gave us the parallel sides, we knew it was a parallelogram, which means that opposite angles were congruent. Here the directions say for what value of x is the quadrilateral a parallelogram. So it's just the converse. So if opposite angles are congruent, then the shape would be a parallelogram. It's the only thing that's really changing, but the math is staying the same. All right, flip on to the back. Next theorem. Now we're going to talk about consecutive angles. If a quadrilateral is a parallelogram, then it's consecutive. Remember, consecutive means right next to each other. Consecutive angles are supplementary.
I still, what's the difference between supplementary and congruent?
Congruent means exactly the same measure. Supplementary just means they add up in 180.
I thought that supplementary was the same as congruent pretty much.
No. So in this diagram, any XY combination is going to add up to 180 degrees. So whether it's these two angles, whether it's these two angles, Bryce and Jamin, whether it's these two angles or whether it's these two angles, depending on which two consecutive angles you pick, they're going to be supplementary of each other. So everybody got that? All right. So let's find the measure of angle B in this example. How will we find B?
180 minus 51?
Right. So the measure of angle B plus the measure of angle C should equal 180. You don't have to show these steps. I'm just putting it in your notes so you have it. The measure of angle C is 51 degrees. So then how do we get rid of the 51? We subtract it. So the measure of angle B would be equal to, what is that, 129? So 129 degrees. I know it's not asking for it. What would be the measure of angle A? 51. And D then would be 129, right? All right, so let's throw some algebra into the mix.
Oh no!
So for what value of x is the quadrilateral a parallelogram? So for this to be a parallelogram, what needs to be true about these two angles? They're not going to be congruent. They're going to be supplementary because they're consecutive angles. So supplementary angles means we add them together and equal them to 180. The parentheses are just there to group the whole entire term and expression together. So combining like terms, x plus 2x makes 3x, 10 and 20 makes 30, equals 180. Subtract 30, 3x equals 150. Divide by 3, what is that, 50? So if x was equal to 50, then that would be a parallelogram because your consecutive angles would be supplementary. All right, so we've got parallelogram. Opposite sides are congruent. Opposite angles are congruent. We have consecutive angles are supplementary. So the last thing we're going to talk about is the diagonals. If I were to create diagonals through my parallelogram, they're going to end up bisecting each other. So if you create both diagonals, what does bisect mean again? Yeah, splits it into two equal parts, right? So if this diagonal is bisected by that diagonal, then it's split into two congruent parts. Same with the other diagonal. Okay, so if you see diagonals, each end of the diagonal, each half, would be equal to each other. So this is equal to that. That's equal to that. So let's go ahead and do the last two examples. Find the values of a and b. Well, a is on this top of the diagonal, which would be equal to which expression on the other side? A equals what?
Wait.
2a minus...
What would the diagonals be to each other?
They bisect each other. So that means, so since it's bisecting each other, this is congruent to this. This is congruent to this. So a should equal 2a minus 8. So if we solve that equation, yeah, subtracting 2a from both sides, negative a is equal to negative 8. A is equal to 8. What would be an equation to solve for b?
B plus 10 equals 3b minus 2.
Good. B plus 10 equals 3b minus 2, which hopefully we all can solve that. So subtracting b from both sides, 10 is equal to 2b minus 2. Adding 2 over, 12 is equal to 2b. B is equal to 6. Oh yeah, space down there.
One second, please.
Yep. Give me an equation for the last one. Good. So again, the directions are just changing to say what value of x would make it a parallelogram. Well, if this was a parallelogram, then this would need to be congruent to that, which means the lengths are equal to each other. So if we solve that equation, subtracting 5x from both sides, negative 8 is equal to negative 2x. So x is going to be equal to what? 4? Okay. All right. Once you have that, grab a practice space. Let's try some of these out and make sure we're good to go before I give you your homework. Yes.